Welcome to section 3.4. I'm going to be on page 403 in your book, and I'm going to give you a quick lesson about Descartes' rule of signs. Now, we use Descartes' rule of signs to determine the number of positive and negative real roots. So when you're doing that remainder theorem and you're storing all the answers and checking, if you know that there are no positive real roots, you don't have to check the positive answers. Or if you know there are no negative real roots, you don't have to check the negative answers. So that's what this is applicable for. And the main thing you do is you look for the number of sign changes. So it's very, very, very simple, especially the positive ones. So what you've got is they're going to give you an equation, and they're going to ask you for the number of positive and negative real roots. Now, for positive real roots, you just strictly look at the equation given, and you look for how many sign changes there are. Well, this one's assumed positive, positive to positive, no sign change. Positive to positive, no sign change. Positive to positive, no sign change. So therefore, there are no positive real roots. So that means if you have your possible rational roots, you don't check any of the positive ones because none of those will work. So now let's see what happens for the negative. So what do you do for the negative roots? Well, what you simply do is you go back into the original equation given and you will put in a negative x. Now, the hardest part about this one is making sure that you have the appropriate sign because it all hinges on signs. So that's negative. In place of this x, I'm putting a negative x, so we're going to cube it. In place of this x, I'm putting a negative x, and we're going to square it. In place of this x, I'm putting a negative x and then a 4. So where these all have x, these all have negative x. Now, in order to check the sign change, we have to really work these out. So, negative x cubed will remain negative. Any negative x to an odd power will remain negative. A negative x to an even power becomes positive. Negative x to an odd power stays negative. This will be the part that you have to make sure you don't make the mistake on. So again, let me say that. If it is a negative x to an odd power, it stays negative. Because what you have here is negative x times negative x times negative x. That's positive x squared times negative x, so negative x cubed. Anytime it's to an even power, it becomes positive because a negative times a negative is a positive. I don't know why that's not erasing. So anyway, let's look at what's happening. Sign change. It goes from negative to positive. Sign change. That's the second one. It goes from a negative to a positive. Sign change. So it actually has 3 negative real roots. Okay, so let's go to the next page, and I'm going to work this one for you. So you have, we want to find the number of positive real roots. So that's your equation. From this term to this term, it's positive to positive, no change. Positive to positive. I think this is the one that I just did. It is. So hold on. Let me try to erase this and put another one up here. Sorry about that. Okay, so first we're going to look at the number of positive real roots. So I look at the sign change. That's considered positive and it goes to negative. So 1. Negative to positive, 2. Positive to negative, 3. Negative to positive, 4. So it has 4 positive real roots because it had 4 sign changes from term to term to term to term. Now, I expect there to be no negative roots. Why would I expect there to be no negative roots? Let's think about it. Our highest degree is 4. If I have 4 positive real roots, then I can't have any other roots. But let's check it out and see. So I'm going to take my negative x and I'm going to put it in here. Okay, a negative to an even power becomes positive. A negative to an odd power stays negative, but negative times negative is positive. Watch me do that again. A negative to an odd power stays negative. Negative times negative is positive. A negative to an even power goes positive. Negative times negative is positive. So let's check signs. Nope. No change. No change. No change. So it has no negative real roots. Excuse me. Okay, I'm going to give you one, and I want you to pause and try it on your own. Okay, pause it. Give me the number of positive real roots and negative real roots. Okay, looking at this, it goes from positive to negative, so that's 1. Negative to positive, that's 2. And there's no sign change, so it has 2 positive real roots. Now, there's one thing I've got to go back and teach you that I did not do because I wanted to wait till the end. So when I put this in here as a negative, all right, a negative cube stays negative. A negative squared becomes positive. Positive times negative is negative. No sign change. No sign change. 1 sign change. So you have 1 negative root. Now here's what I need to go back and teach you. Do you remember when we do irrationals, you have pairs. You have a positive and a negative. Irrational numbers or irrational roots must come in pairs. That means groups of 2. So if you have an x to the 4th equation, you can have 4 real, you can have 2 real, and 2 irrational. But you cannot have 3 real and 1 irrational because all irrationals are groups of 2. Or you can have 4 irrational. But you cannot have odd numbers of irrationals because of this right here. They always come plus minus. So there's always, even if it was an imaginary number, it comes plus minus. It comes in groups of 2. So let's go back to the beginning, and I need to make one little correction here just to add to it. Now, right here, you have 0 positive real roots. That's as low as you can go. On this one, we're going to go back and we're going to account that we can have 3 negative real roots, or we can have 1 real root, because we would have 2 irrationals. Now, you don't have to put the 2 irrational, but what we're going to do in order to get the number of reals, we're going to subtract 2 every time because of the 2 possible irrationals. So I have 3 negative reals or 1 real because of 2 irrationals. But all I'm looking for is 3 or 1. You're going to subtract by 2. Right here, I could have 4, I could have 2, or I could have none. So just keep in mind that you're going to subtract by 2. You could have 4 reals, positive reals. You could have 2 positive reals and 2 irrationals, or you could have no positive reals and all 4 irrational. So you can have 4, 2, or 0. Of course, when there's none, you leave it like that. Now on this one, we had 2 positive reals. So my final answer would be 2 or none. Now on this one, if we subtracted 2 from 1, we would get into negative 1. So we can't have a negative 1 answer as far as like negative 1 number of answers. So as low as you can go is either 1 or 0. So let's try another one where we're going to have a great big number, and then I'll let you go to Canvas. Okay, so let's do this one. All right, great big long one. Okay, so let's count up our number of sign changes. 1, 2, none, 3, 4, 5. So I have 5 positive real roots, or I have 5 minus 2 is 3, or 1. I could have 5, 3, or 1 positive real roots because irrational roots come in pairs. So let's check the negative. Make sure I got everything correct there. All right, raised to a positive, even power, it becomes positive. Odd power, it stays negative, so negative times negative is positive. That goes positive. That stays negative. That goes positive, but positive times negative is negative. That goes negative. So no sign change, no sign change, 1 sign change, no sign change, no sign change. So I have 1 negative real root. So here I can have 5, 3, or 1, or here I have 1. If you start off with an odd, the lowest number you can go to is 1. If you start off with an even, the lowest you can go to is 0. So I want you to now go to your quiz on Canvas just as a daily work and try that one for me.